that will follow from the mentaculus. Basically, the argument will be connected to this tree picture. It's more complicated than that, though, because there'll be some situations in which we do have influence over the macro past, but it'll turn out to be useless. We can't use anything about it because we can't know about it. The reason we can't know about it is that there would have to be a kind of record in the present of whether or not what actually happened in the past for us to have real influence over the past. But of course, if there is a record, then we're holding that fixed. And so either our alternative decision will change that record, we'll get rid of that record, which we don't think it'll do, because we don't think we'll have immediate control over the record, or that record will, so to speak, screen off, is the word that people in probability theory use, screen off the alternative decisions we make from the macro state of the past. So it will follow from the mentaculus that we can't have any kind of useful control over the past. Useful influence over the past. Now, control you might think of as a bit more than influence. Control is not just influence, but it's influence that is a kind of robust. We would continue to have it as various things change. That's certainly right about our body. You know, I can control how my hands are moving pretty much independently of what's going on outside of this room, I hope. Okay. But that's, in those cases where we have influence over the past, even macro influence over the past, and there are some cases like this that have been thought up by a philosopher who's now down the road from here in Munich, Matthias Frisch is the person you know. In those cases, it's not control, because it's not robust, because it really depends on there not being these external records. Because if there were external records around, then we no longer have influence. That argument, I do not think I made sufficiently clear, but that's the argument. Okay, I'm almost at the end of the talk. I'll be happy here. What I think comes out of this discussion, though I was very sketchy, is that just on the basis of the mentaculus, you can explain four things. The very low likelihood, minute likelihood of aberrant microstates. The second law of thermodynamics in its probabilistic form. But more importantly for the crime project, the asymmetry of memories and records, why we don't remember the future or don't have records in the future, why we have so much more knowledge of the past than we have records of the past. And very interestingly, the asymmetry of control. Because I think it's the asymmetry of control, influence and control, which you understand. I'm not saying it's a complete asymmetry. We have this micro influence over the past. That's what gives us the feeling of time flowing. Or rather, it's the two together, the accumulation of memories, together with that we make a difference, can make a difference to the future, but not to the past. That, I think, is an incredible consequence. Well, incredible means unbelievable, doesn't it? I meant it in the sense of being fantastic and wonderful. Okay. This probabilistic distribution is there in the objective world. I think if there is causation, contrary to Russell, but with Russell, because it's not fundamental, then it's got to be grounded in these correlations. Tomasz will tell us, I think, something about that later. Okay, let Edwin know pretty well. We have this idea that we have this sort of libertarian free will. Now, some philosophers have kind of poo-pooed and say, oh, you don't really have this idea. And there have even been some so-called experimental philosophers who think they've discovered that many ordinary people don't have this idea. I don't think their experiments are very good, and I don't think that's right. But in any case, I have a libertarian conception of free will. So I think free will really involves, my conception is, it's up to me right now, damn the past. But then I think about physics, and I think I've learned that determinism is true. And even if probabilistic quantum mechanics, some version of quantum mechanics which involves real propensity probabilities was right, I don't think that helps with libertarian free will at all. So I'm in a conflict. Kant was in that kind of conflict, and he said, calm down, everybody, because there's free will in the noumenal world, even though there's determinism in the phenomenal world, and that was supposed to make you happy, but I never understood that. Okay. But I'm saying, as you'll see in a second, I'm going to end up saying something like that. And I didn't realize that until this moment. Here's what you might say on this picture. You know, there's no libertarian free will, really. The micro, it goes the opposite of Kant in a way. The micro world, if it's deterministic, then the state of the world a million years ago does determine its state in the future. But of course, it stayed in the future in terms of state in the past. So you kind of are liberated somewhat from this past determining. I think once one feels that, one has a kind of Buddhist-like feeling, and you think maybe, you know, this free will illusion goes with the illusion that the past-future distinction is basic. There's a real distinction there, it's not basic. Well, maybe somebody could pick up the ball there and carry it a little distance. But I'm going to go a different direction. What is a very interesting thing about the mentaculous probability distribution, and it's this, that the macro state right now, what's actually accessible to me by way of knowing about you, or even knowing about myself before I make a decision, is not sufficient for determining the future. It's all probabilistically chancy. So that really kind of supports the illusion that it's not determined by the past. It's definitely not determined by the macro past, if it's the case that our decisions correspond to more or less small, they don't have to even be micro, but smaller than what's accessible to us states. Well, that's a point that many people have made in various guises, but here you can see at work in this metaculous probability distribution. And there's another interesting thing here, too, that sometimes people are worried about. There are kind of lawful, this kind of look like something like laws about human behavior. You know, there's a probabilities about teenagers taking up smoking. These are not really such strong laws. On the other hand, we think there's lawful correlations. On the other hand, we think we can convince. Sorry, Alessandra, for the example. I thought of the example just now. I was looking at you. And, we think of these things, you know, as kind of lawful, but that we can convince people not to smoke. Or you think of a lot of examples like this. And people have often been very puzzled, Popper for one actually, puzzled about how these can fit together. The metaculus fits them together because it's the case that pretty much any macro probabilistic correlation can be defeated by more fine-grained descriptions. Not everyone can. For example, gambling devices will not be defeated by anything much short of the exact microstate of the world. But for many, many other situations, the macro probabilistic correlations can be reversed in Simpson's paradox kind of ways, really, by finer macro descriptions. And that's a consequence of the mentaculus. You look how the probabilities work, and you see that. So I think this also encourages a kind of illusion of free will. So I got very excited when I thought this was, but now I can ground that, decry that as well. So here's the end of the talk now. So here's the way all of this thought went. It's a very big picture. Question, how can the temporally asymmetric laws of thermodynamics and the non-existent invariant trajectories and so on be reconciled with the temporally symmetric dynamical laws of fundamental physics? Solution, the mentaculus. The mentaculus imposes a probability distribution over all physically possible trajectories, resulting in conditional probability distribution over all pair of macro propositions. That's the Carnap dream of physics. The Tim Williamson dream that you should accept. Of course, there are important differences. You've got to accept certain fundamental physics, and I'm not telling you the logical probabilities that go beyond that. This probability distribution, I've argued a little bit, and there are a lot of papers and discussions about this now, grounds times arrows. And it also explains why we seem to possess